Hello everyone, my name is Chamath Amarasinghe. Today I'll be presenting SipBit, a beverage sensing platform based on electrical impedance spectroscopy or EIS and deep learning. Food sensing and determining internal attributes of food such as ingredients is an essential aspect of human food interactions or HFI, but it remains a significant challenge. Computer vision is broadly employed in food sensing and it's highly effective in discriminating food. However, it faces challenges when identifying the quantity of the food and estimating ingredients because changes to ingredients are not typically reflected visually and due to the absence of depth information. When it comes to food sensing, there are many non-visual techniques. EIS is one such technique that involves measuring impedances of food and beverages across a range of frequencies to determine their properties. In this work, we introduce SipBit, a beverage sensing method based on EIS and deep learning to determine beverage type, volume and sugar content. The first component of our system is a 3D printed attachable module with two electrodes that are immersed in the liquid. Next, the impedance analyzer measures the impedance across two electrodes in a range of frequency. Finally, these impedances are sent to the computer via a microcontroller for analysis. So far, we have collected data from 8 beverages. We used a type of deep learning framework known as multitask network cascade, also known as MNC in short, to determine beverage attributes. This network has 3 outputs and each output has a corresponding set of hidden layers called stages. Furthermore, 2 types of MNCs were implemented based on principal component analysis or PCA. One network accepts impedances and imaginary part of impedances as input features, while the other accepts PCA processed data. Although results demonstrate close performance between two models, an overfitting was observed in the model with PCA. Therefore, the model without PCA generalizes beverage attribute determination, making it the better option. The platform we introduced could be applied to different HFI applications, such as food and beverage journaling, virtual flavors, and food quality assessment using wearable devices. For example, impedance-based technology like SipBit could be integrated to cutleries to recognize and record users' food intake in the case of food and beverage journaling. In summary, we present a platform that combines EIS and deep learning to recognize beverages, their volumes and sugar content. In future, we hope to expand the number of beverages in the SipBit's dataset and integrate additional beverage attributes such as salt content with the aim of developing a more robust beverage sensing platform.